Okay, good afternoon, everyone. So today we will go to the fifth module of plant utility system. So now we will discuss about combustion system, and also later we will discuss about boiler system. Yeah, maybe before I continue the lecture, maybe I can ask one of you. Can you still remember, or can you explain why in industry, in chemical plants, we need a combustion system, or what will be the function of a combustion process?
For energy, sir?
For energy, can you elaborate your sentence, please?
So this combustion process will transfer its energy used to combust something for electricity inside the plant, sir.
Okay. What will be the form of energy from the combustion?
Heat, sir?
Sorry?
Heat from heat.
Yeah, it's heat. Yeah, so basically, in chemical plants, we do the combustion process basically is to provide heat, and later heat can be used in other process unit. For example, can you name the example? The heat, you can use the heat for what? Other student perhaps? Hadian, are you there? Hello, Hadian. You are in the Zoom, but can you answer my question? Okay, Gamma.
Yes, sir.
Yeah. From combustion, you will get heat, right? You will get heat, and then in chemical plant or in process industries, what will be the function of the heat?
You could generate electricity. For example, you could use it to spin a turbine, and then the turbine will create electricity.
Okay, what kind of turbine that use heat for to generate electricity?
Steam turbine?
Yes, steam turbine. So basically, you can use heat to provide steam. Yeah, to increase. Basically, you can use energy in the form of heat. Yeah, in the form of heat to increase the temperature of something, right? So maybe the something is water, for example. So if you increase the temperature of water, it can change the water into steam, yeah. So the phase change from liquid into vapor, of course, not only by increasing the temperature, but also increasing the pressure. Then it becomes steam, and the steam can drive the steam turbine, and then the steam turbine can generate electricity. That's one of the function. Maybe for other function, basically from the heat you can increase the temperature. Why we need to increase the temperature? Maybe in some reaction, yeah, in the reactor, the reaction is only happen when the temperature is maybe at a very high temperature. So you need to provide heat. That's why you provide combustion. Okay, my other question for other student, how you conduct combustion? Maybe you still remember from the very first of the plant utility systems lecture. How you provide combustion? Or what is combustion, basically? Fatia.
You basically supply enough oxygen.
Only oxygen?
Or air in general.
Only air? Still remember, right? Combustion triangle? Did Pak Miki explain about the combustion triangle? I forgot, Pak Hendra.
Yes, he did. I think so.
Yes. What is the combustion triangle?
It was oxygen, heat, and fuel.
Yeah. So you need oxygen, you need heat, and you need fuel. So you basically in combustion, you burn, you oxidize the fuel, and you provide heat. So the combustion occur. So basically the combustion will occur between the fuel and the oxygen. And My other question, what will be the product of the combustion? Diah Ayu. Do you still remember?
Is it carbon dioxide and H2O?
Yeah, the product is the carbon dioxide and water only if what? Or what will be the prerequisite if the product is only carbon dioxide and water? Still Dia?
If the it contains CNH, maybe.
It contains CNH. Okay, but if only the fuel is basically the hydrocarbon, right? Hydrocarbon, yeah, you have hydrogen and carbon and maybe other atoms in the fuel. But basically you burn C and H and O, hydrocarbon, right? With oxygen. So if you want the product is only carbon dioxide and water, syaratnya apa? Or what will be the condition that has to be met? Damalia?
I'm sorry, sir, could you repeat the question?
Yeah, okay. Basically, combustion is a process of the oxidation of fuel, right? So you oxidize the fuel, so you can get heat. Besides you obtain heat, the product of combustion will be CO2 and H2O, yeah, carbon dioxide and water. But that's not only the product, right? So the product is only CO2, water, and heat only if what? If the combustion happen perfectly, right? So what we call, I don't know the terms, is called complete combustion or perfect combustion, pembakaran sempurna. Yeah, the complete combustion is only happen if you provide enough oxygen. That's why in combustion, if you want complete combustion to occur, then you need to provide excess air. You still remember, right? Yeah.
Yes, sir.
Okay. So if you do not have excess air, so maybe you have less air than stoichiometrically required, what will happen? Or we call it incomplete combustion.
You will get the complete combustion then. So the product, there would be carbon monoxide.
Yes. So you will get another product. Sometimes it's carbon, sometimes it carbon monoxide, and others. So basically, in real life, the complete combustion is it won't happen naturally, right? So it won't have basically in combustion you will get additional products like carbon or maybe carbon monoxide, and maybe if you do the reaction, the combustion reaction, because the reaction is between fuel and air, right? Air itself, it contains nitrogen. So if you conduct the reaction in very high temperature, some of the nitrogen will be oxidized into NOx. Yeah, so there will be a lot of side products of the combustion. Yeah, just for the preview of this lecture. Okay, maybe from our discussion, yeah, from Pak Miki about fuel, we have learned so far about the combustion stoichiometry, and then you learn about to calculate the theoretical air, yeah, the how much air that theoretically required for the combustion, and then estimation for the calorific value or heat value. So later in this chapter, we will extend our discussion about adiabatic flame temperature calculation. So later, next week, basically by Pak Miki, you will learn about the calculation of energy balance in combustion. and we also learn about the heat loss assessment. Yeah, so basically, when you have this is the one of the unit that use not combustion. I mean, use heat from the combustion is to generate steam. Yeah, the device called boiler. That's why we will discuss about the boiler in this chapter as well. So you will have water, yeah, as the raw material, and then you will have air and fuel, yeah, for the combustion process, and then you will have water heated by the heat from the combustion. Then you will have steam. Then not all of the heat from the combustion process will be converted into steam. Yeah, so some of the combustion gas or the product of the combustion will be in the gas form, right? Some of the combustion gas will go as the flue gas. Yeah, and some of the combustion will form what we call fly ash and bottom ash as the side product of the combustion, depending on what kind of fuel that we will use for the combustion. Okay, this is as the preview. This is the representative of adiabatic flame temperature. So basically, when you use a different kind of hydrocarbon as fuel, then you will have a different adiabatic flame temperature. Adiabatic flame temperature is basically correlated with how much heat that you will get by burning that kind of fuel. Later we will discuss it about this one. Okay. Now we will discuss first about how different types of fuel will be affecting the combustion process. So basically, fuel can be classified into two categories based on the phase. We use solid fuel. Coal is one of the example of, and the common example of the solid fuel. Yeah. So when you use a coal or solid fuel and you want to burn the coal, so basically you need to arrange this combustion process. Yeah, you need to arrange the coal into certain arrangement so that the combustion can occur. So basically you will have two types of arrangement of solid fuel combustion. First, using what we call fixed bed. Yeah, fixed bed means the solid one. Yeah, you arrange the coal or the solid fuel into stack of solid. Yeah, and during the combustion, the solid is not moving. Yeah, that's why we call it fixed bed or unggundian. I think you already learned this term in fluid mechanics. Hopefully you still remember. Yeah. The other version is by make fuel in the suspension. Yeah. So in this type of combustion, the solid will be moving. Yeah, the moving can be in the form of suspension of fuel within the injected air or in what we call fluidized bed combustion or FBC. So basically, fixed bed and FBC is the common types of solid fuel combustion system. And previously I mentioned about the ash. Yeah. So if we burn coal, you will get ash as the side product of the combustion. Ash itself classified into two types. Yeah. First, the very fine ash. Yeah, the very fine particle, we call it fly ash. Yeah, this is very fine particle. The surface is very, very smooth. Why we call it fly ash? Because this particle, it's solid, right? It is entrained. It is, you know the term entrained, right? Have you heard this term entrained? What does it
I don't know, sir.
You already get your OPD class, right? Separation. Oh, but I think, have you learned about the distillation column? The design of distillation column in separation process?
Yes, sir.
Have you heard about the entrainment? It's the same phenomena basically, but just the different phase. Entrainment. So basically, this is the process where the solid particles being carried away by the flue gas. That's why we call it fly ash, because the ash is flying. Yeah, it's entrained by the stack gas. So before the flue gas can be released to the atmosphere, we need to put something, yeah, some equipment, some additional equipment to prevent this fly ash comes into the atmosphere. Because fly ash is one type of the particulate, right? It's very small particle. So if you release it to the atmosphere, then people that live around this chemical plant will inhale the air that containing the fly ash, and it's very, very dangerous. That's why we installed like a cyclone or bag filter, or maybe the electrostatic precipitator to capture this fly ash. Yeah, one is fly ash, the other one is bottom ash. So, but by the name, you know, this is the one that doesn't carried away by the flue gas. It stays at the bottom of the combustion system. Yeah, so the particle is bigger, it's coarser, the surface is rougher, and can be in the form of granules or lumps. Yeah, so it's big, and then it will be collected in the bottom of the combustion chamber. In this bottom ash, the content of unburned carbon will be higher than the fly ash, because the bottom ash is basically represent part of the coal or part of the solid fuel that doesn't burn. So it stays at the bottom of the chamber. Okay, maybe we discuss first about the fixed bed combustion. Fixed bed combustion, the size of the particle, yeah, it should be around this much, 3/4 until 2 inches, and then the particle is being stacked up in the column, and then you will have two types of air, yeah, to burn the coal. The first is the primary air. Yeah, this is the primary, by the name, is the air that mainly used for the combustion and has a higher flow rate, higher velocity compared to the secondary air. Yeah. So the combustion happen, and basically in fixed bed, yeah, you will have 4 different zones from top to bottom, yeah, regarding the combustion. The first one is, we call it the gas combustion completion zone. So it's basically the reaction between VM. VM is the volatile matter, react with carbon dioxide, carbon monoxide, and react with the oxygen to form carbon dioxide and water. Okay, the second one is the drying, or we call it the distillation, yeah, because I think, correct me if I'm wrong, Pak Hendra, because if you burn the coal, in the coal, it's not only carbon, right? So you have carbon, you have other compounds, including the volatile matter. So when you burn the coal, some of the volatile matter will, by the name, yeah, it will evaporate. So, sorry, yeah. So in this fixed bed, basically from the bottom to top, the volatile matter will go upwards, right? So it's why we call it the volatile matter distillation zone. Distillation, by the name, yeah, it will be separated due to the titik didih, boiling point, yeah, by the boiling point. Okay, and then the layer number 3 and number 4 is the combustion zone. So the combustion zone, one is the reduction zone, which is the reaction between carbon and carbon dioxide, and the oxidation is between carbon and oxygen. Yeah, and the last layer, yeah, basically it's the leftover of the combustion. This is the ash. Yeah, so basically the ash will protect the grate is this one, the one that you use to support the stack of the solid. Yeah, the S layer will protect the grate from the overheating, and then preheat the incoming primary air. Okay, fixed bed is basically the oldest technology. Yeah, the oldest, the cheapest one. And then you need to have the coarse particle. Yeah, you cannot have a very fine particle. Do you know why? Why in fixed bed you need to arrange, or you need to make sure that the size of the particle should be coarse. Coarse means kasar, not very small or fine. Because if you stack the coal and the size is very fine, you might get a very small void fraction. You still remember, right? Void fraction. So if you have very small void fraction, then the pressure drop of the air that flowing from downward to upward will be very high. So the combustion cannot be done optimally. Yeah. So you need to have a optimal void fraction in between the coal. Okay. However, this fixed bed has low combustion efficiency because some part of the coal might not be burned, right? Because you have a very dense structure of coal. Okay, any question? I hope not. Okay, any questions so far? Okay, if you do not, yes?
All good, sir, all good, sir.
Okay, then this is the example how you arrange the coal into fixed bed. So you have a spreader stroker, yeah, or chain grid stroker. So basically the coal will comes from the hopper and then goes to the feeder. From the feeder, it goes to the spreader that will spread the coal to form the bed. Yeah, so they can layer on the top of the grid, and then primary air will come from the down part, and then the secondary air will come from the side. Okay, the other one is what we call chain grid. So the chain grid, the grid can move to help the coal that comes from the hopper to line up as the fixed bed. Okay. The other one is what we call pulverized fuel combustion. So basically, this is the type of the solid fuel combustion that now commonly used in many power plant or many chemical plants, because this pulverized fuel combustion will have a higher capacity, yeah, than fixed bed combustion, and then it also have faster ignition process, hence faster combustion. Then the size is smaller, yeah, that we call it pulverized. It should be pulverized, so the fuel particle size will comes around from 65 to 85%. The size is 200 mass. Do you familiar with the size of the particle in mass unit?
No, sir.
Have you not heard about this one? Mass?
No, sir, I don't think so, sir.
Okay. Masa belum pernah diajari ya? Okay, maybe is it in lab tech or in other lecture? So basically, mass is by the name, right? Mass is this one. What we call it? Yeah. Okay. Yeah. Mass is looks like a net of something. Yeah. So 200 mass, if I'm not mistaken, from 1 inch square, you will have 200 holes. Is it correct, Pak Hendra?
Ya, Pak. Correct, Pak.
Yeah. So it means the larger the number of the mass, the smaller the particle. So the particle that can go through the holes, it means, so you compare, let's say 100 mesh. 100 mesh mean in 1 inch square, you will have 100 holes. This one is the holes. It means it will have bigger size, right? The holes should have bigger size. 200 has smaller size. 300 then smaller size. So this mesh, I think you should start remembering this unit. So basically, this unit is usually used if you want to calculate the size of the particle. It represented it in mesh. It's the strainer, ya. Saringan, bener nggak sih? Ya, it's the saringan. So 200 mesh means 1 square inch will have 200 holes. So it's around the size. Then you can see later, you can check from the Google or from the textbooks what will be representing 200 mesh into size particle size. So it's pulverized into this size, and then we need to suspend the fuel. It means you need to make the particle into the suspension mode. So the suspension, the air that is required to suspend the fuel is around 10 to 20% of the total air required for the combustion. Okay, the fuel air suspension is injected into the combustion chamber by specifically designed what we call pulverized fuel burner, yeah, or we call PC burner, or it stands for the pulverized coal burner. And this type of burner or combustion system is now widely used in power plant boiler, or we call it pembangkit listrik tenaga uap, ya, PLTU. Okay, this is the configuration of the PC burner. So the name represents the position of the burner. It can be in horizontal form, it can be in the vertical form or tangential form, or even in the cyclone form. Okay, I think before we go into the next type of the burner, I have one animation, I think one video about the pulverized burner. Let me share it for you.
Coal is the most preferred fuel used in a reheating furnace because of its easy availability, low cost, and ease of operation. Coal used in the pulverizer needs to be of a higher grade and is sourced from coal mines in Assam or some other parts of the northeast, or imported from countries such as Indonesia, South Africa, or America. Conventionally, the pulverized coal is conveyed with cold combustion air without the provision of a recuperator and fired by a 4-inch pipe. As there is no proper control on the fuel and air, the process leads to improper combustion, resulting in unburnt coal. Also, the pulverizer, in most cases, is inefficient. In the energy-efficient process, high-quality lump coal is first fed into a pre-crusher wherein coal is crushed to tea-leaf size. The pre-crushed coal is then passed through the dryer where the surface moisture of coal is removed using hot air from the recuperator. The coal is then fed into the pulverizer where it is powdered to 75 micron size. The pulverized coal is then transferred to the overhead furnace hopper, which allows storing of coal in the required quantity at the furnace head. A DC motor-run screw feeder controls the coal flow to the burner based on the furnace temperature. A swirls-type burner with annual arrangement for separate entry of coal and hot air and equipped with circumferential vanes is used in the system to ensure proper turbulence and mixing of air and fuel. The process is completed by feeding preheated combustion air from the recuperator to the burner tip, which along with the swirling motion improves the combustion significantly, leading to lower specific fuel consumption and burning loss. The improved system can be used for any capacities of reheating furnace. The coal handling and feeding system, including dryer, in a typical 10 TPH furnace can cost around 6 to 8 lakh rupees, resulting in a reduction of specific fuel consumption by 20 to 40% from the conventional system. Thus, the investment made can be recovered within less than a year. The efficiency of the system can be improved by ensuring use of high-grade coal with low ash content, high-efficiency recuperator, and installation of automation and control system.
Okay, the first video tells you about how you handle the pulverized coal, and the second one shows you the type of the PC burner. Yeah, you can see how the pulverized coal is being connected to the burner, and the construction of the burner, and how the flame comes out from the burner. Okay. The next one is the fluidized bed combustion. So the fluidized bed combustion, is my sound is still clear, or is it?
Yeah, it's clear, Pak.
Yes, Pak?
Yeah, it's clear, Pak.
Okay. Because sometimes I forgot to reset the sound system, the setting of the sound. Okay. In the fluidized bed combustion, fuel is converted into finer powder. Yeah, so it can be fluidized by the combustion air, and then the coarser powder particles will float, and the finer particles may be entrained by the air. Why we need to form a finer powder? Yeah, because we want the fuel and the air to be very well mixed. Yeah, so the combustion can happen in more perfect form. Yeah, so in fluidized combustion, we can simultaneously conduct the desulfurization. Yeah, because side product of the combustion is the sulfur dioxide. So to capture the sulfur dioxide, it's basically you react with the calcium oxide powder to form CaSO4. Yeah, we call it gypsum. So this gypsum will exit in the combustion chamber along with the ash, and then before the gas is being released, you need to install the cyclone to catch the ash and the gypsum, and then it will go through the bottom part of the furnace together with the bottom ash. Yeah, in fluidized bed combustion, the temperature can be reduced until around 900 degrees C, so it can reduce the formation of Nox, and also to prevent the ash fusion while maintaining the SO2 with the formation rate. The modern variation now in the pressurized FBC, yeah, the pressure of the fluidized bed is increased until 10 to 15 atm. And then the high pressure combustion gas is first fed to the gas turbine, yeah, to generate power before being used to steam generation. So the gas can be used for two purposes. So it can increase the energy efficiency and the overall combustion system. So in the boiler, yeah, you can see the step of the process. Yeah, the fuel and also the limestone. The limestone is the CaO, will enter the furnace, and then in step 1, and then in step 2, the air fans will push the fuel, limestone, and ash mixture upward, and then fuel particles reduce in size and then broken down to particles to enter the hood loop. And then after that, smallest particle carry out in the flue gas as fly ash. Flue gas will pass through, yeah, through heat recovery area to heat steam and also for the turbine. And then the dust will collect it through the EP, or we call it electrostatic precipitator. Long particle resistance time in combustion chamber because it has to go through several steps, right, and several lengths of the combustion in the furnace system, right? So the length particle residence time in combustion chamber, it will facilitate a more complete fuel combustion at lower temperature. Limestone injection is also, I have mentioned, is also to remove the sulfur impurities in the fuel. Okay, I think I have one other video about animation of the circulating fluid bed boiler.
Sumitomo SHI-FW is advancing steam generation technology with its state-of-the-art circulating fluidized bed technology. Due to its fuel-flexible low-temperature burning process, CFB technology can utilize all types of coals, lignites, petroleum cokes, and carbon-neutral fuels, like biomass and recycled waste, to produce clean and economical power generation. It offers a major advantage over the limitations of conventional combustion, the ability to burn the widest range of fuels. Conventional coal technology requires the fuel to be finely ground and dried before entering the furnace. These steps are not needed for the CFB. Instead, the fuel is coarsely crushed and dropped into fuel chutes which lead to ports in the lower section of the CFB's furnace. Unlike conventional boilers that burn the fuel in a massive high-temperature flame, CFB technology utilizes circulating hot solids to cleanly and efficiently burn the fuel in a flameless combustion process. Its low uniform combustion temperature minimizes the formation of nitrogen oxides and allows the injection of limestone to capture acid gases as the fuel burns, giving the CFB the lowest furnace emissions. Since the fuel's ash doesn't melt, heat transfer surfaces stay clean, allowing the hot solids to conduct their heat efficiently throughout the entire boiler while fouling and corrosion are minimized. The payoff? Low plant emissions, low maintenance, and high plant reliability. To achieve very high combustion efficiency for all fuels, the solid particles in the furnace are collected by steam-cooled solid separators which recycle most of them back to the furnace. Before re-entering the furnace, the particles pass through a high-performance Intrex heat exchanger where steam coils are submerged in a bubbling bed of hot solids to efficiently produce high-temperature superheat steam. To further reduce plant operating costs and emissions, our CFBs can utilize vertical tube supercritical steam technology to achieve the highest plant efficiency. And for full capture of greenhouse gas emissions, we offer FlexiBurn CFB technology which can produce a CO2-rich flue gas for beneficial use by the oil, agricultural, chemical, and construction sectors. Circulating fluidized bed technology is an important part of the solution to meet the world's energy needs while conserving natural resources and preserving our environment. Visit us at shi-fw.com for more information on our
Yeah, that's one example. Actually, it's the product video from one of the supplier. It's about the one types of optimized CFB boiler. Okay, I hope from the animation you can get the representative picture how the CFB boiler is operated. Okay. Any question until this part?
Sir, I have a question, sir.
Yes.
How does the Cyclone work, sir?
Yeah, the Cyclone by the name is basically it use the, hopefully I name it correctly, it's the centrifugal and with C, yeah, and centripetal force. Yeah, it creates the rotation movement, so it rotates, so it creates the centripetal and the centrifugal motion, yeah, the force. So the air will be moving in the rotation movement, so it will experience the centripetal and centrifugal force as well. What will happen? The air will contain the ash, right? The fly ash, and then the entrained gypsum and other particulates. So this particulate will settle down because of these two forces. Yeah, that's the basic principle of the cyclone. That's why it can be used to make sure the solid particle, the small solid particle that being flown by together with the flue gas to go downwards and collect at the bottom of the furnace. That's the basic principle of the cyclone.
Okay, sir. Thank you, sir.
Okay, it's like a tornado. Like the movement is because the shape is like tornado, right? So when it moves, then it will it will suck the solid particle downwards. Tornado or twister, something like that. Okay, any other question?
Sir, I have a question.
Yes.
The slide before this about the circulating fluidized bed boiler, Is that part of the fluidized bed combustion, or is that like a separate thing? Or
Oh yeah,
Oh.
basically, this is types of boiler that using the fluidized bed combustion system. Yeah, so the heat from the combustion will be used to create steam from the water. Yeah, that's the function of the boiler. Yeah, the heat comes from the combustion of the coal, and the coal will be formed in the fluidized bed. Yeah, together with the air. Air will be used to burn the coal, right? So air and the particle of the coal will mix and then will create the fluidized bed. So the combustion occur in the fluidized bed. So this is the type of the boiler based on the type of the combustion system to the boiler.
Okay, sir, I understand. Thank you.
Yeah. Okay. Any other question? Okay. If no more question, then I'll continue to the second type of the combustion system. So this is the liquid fuel combustion system. So based on the name, the phase of the fuel is in liquid. Before liquid can be burned or be combusted, the liquid has to be vaporized first. So the combustion basically happen between the vapor of the liquid and the air or in the oxygen. Yeah, the vaporization can be achieved by the natural, either by natural vaporization, yeah, with the temperature, because fuel have vapor pressure. Yeah, please remember again your fluid mechanics class. What is the definition of the vapor pressure? And then also the vaporization happen with through a wick of the tube, yeah, small tube. We call it a capillary tubes to transport the fuel. Yeah, so basically when you increase the using the small tube, the liquid will have the capillary phenomena, right? So while it goes up due to the capillary phenomena, it will also get vaporized. Yeah, it's also will related to the vapor pressure of the liquid itself. And then the third one will be by the spraying or atomization. Atomization is basically not change the fuel into atoms, but change the liquid into a very fine droplet. Yeah, that's we call it spraying. Yeah, so atomization is just the name. It's basically not creating the atom, but just the creating the small, very fine droplet. So it's increasing the surface area of the liquid, so increasing the vaporization rate. Also, we can use the higher temperature to increase the vapor formation. Yeah, the burner is basically is based on the how you vaporize the liquid. It can be in vaporizing burner, or it can be a spray burner. Spray burner can be in the pressure atomizer, rotary atomizer, or gas atomizer using steam or air. Yeah, this figure represents different types of burner used to burn the liquid fuel. Okay. Now, but the performance of the combustion system. So basically, combustion system performance can be evaluated in terms of the efficiency, carbon combustion efficiency, because a high combustion efficiency is basically very important to increase the overall efficiency of the power plant. We may encounter carbon losses, which means part of the carbon contained in the fuel is not converted into heat, yeah, because one is because of the gas entrainment or the carryover. The second one is from the incomplete combustion, so the carbon remains at the bottom. And the third one is the S entrainment. Okay. Operation, the variables that influence the carbon combustion efficiency will be, one is the temperature of the bed. Yeah, generally the higher the temperature, the combustion will be more efficient. However, if you use very high temperature, there will be formation of NOx, yeah, the oxidation of the nitrogen in the air, and also the formation of SOx, and also S fusion. I think Pak Hendra, can you explain a bit about S fusion? What does it mean?
Oh, Pak, the S, which one, Pak? S fusion?
S fusion. What does it mean by S fusion? I try to find out what does it mean, but I cannot find the. It's okay if you do not know, then we can ask Pak Miki later.
I think the residue of the ash, Pak, remaining from the combustion process, Pak.
So it will be why the term is fusion?
Maybe it is actually produced from the fusion process. If I'm not mistaken, if
Okay.
yeah, reaksi
Okay.
fusi, Pak. If yeah.
Oh, so from the fusion reaction. Okay.
Yeah.
Okay. Then the other variables. Thank you, Pak Indra. The other variables that influence the efficiency of the combustion is always the excess air, right? Because if you have excess air, it means you provide more oxygen. It means you improve the efficiency. Then the other one is the velocity of the fluidization. If you use the fluidized bed combustion, if you increase the velocity of the air, then you will also increase the possibility of the carryover, the entrainment. So the part of the solid will goes up. It's not burned, but just goes up to the top part of the burner. And also decreasing the velocity will improve the efficiency, yeah, because the contact between air and the solid will happen in the better manner, but you need to provide more space. Yeah, it means you need larger chamber to provide the contact to happen, to provide the same amount of the heat. Okay. How about the NOx formation? NOx can be in the form of NO, NO2, NO3. It's basically air pollutant. It's also toxic, yeah. So the concentration, this is the regulation, but I forgot which this regulation comes from. And NOx formation is basically comes from the high temperature combustion. Okay, then how to reduce NOx formation? Of course, you have to reduce the temperature. So low temperature is basically can be achieved by using the fluidized bed compared to the fixed bed. Yeah, at this condition, the oxidation of thermal NOx formation. Yeah, thermal NOx is NOx that comes from nitrogen in the air. Yeah, the oxidation of nitrogen, yeah, reaction between nitrogen in the air with the oxygen in the air in very high temperature, we call it thermal NOx. It can be from NOx, but only result from the combustion of nitrogen compounds in the fuel itself. So maybe the coal or the biomass, maybe if you are using biomass for the combustion, it will contain nitrogen compounds. So if you do the combustion in low temperature, you might find NOx, but it's called fuel NOx. Fuel NOx is NOx from nitrogen in the fuel, while thermal NOx comes from the nitrogen in the air. Okay, until this part, any question? Have you learned about SOx and NOx in PLIK?
Yes, sir. Partly, sir.
Yeah, about the danger, and then where it comes from and how to treat the SOx and NOx. I think you have learned it in PLIK, so please don't forget that that part of the course. Okay, if you have no question, then we will go to the second part. So basically now we will discuss about the steam boilers. Yeah, so we have discussed about fuel in the first lecture, what types of the fuel, how to calculate the calorific value of the fuel, And then we have discussed about water, yeah, water, and then where we can get the water, what will be the chemistry of the water, what will be the main problem with the water if you do not treat it properly. And then if you want to use water in the industry, what kind of treatment that you need. And also previously we learned about the combustion, yeah. So in this part, we will discuss about the device that will convert water using the combustion system. Yeah, we call it a boiler. Yeah, boiler is device that we will use to generate steam. Okay, what is boiler system? So boilers or steam generator is basically a collection of equipment that we use to convert chemical energy in fuel, yeah, to convert chemical energy to thermal energy or latent heat in steam. Yeah, steam will bring the chemical energy in the fuel into the thermal energy or latent heat. Okay, so basically, boiler system will consist of combustion air handling. Yeah, so because it needs combustion, right? So it will have the combustion air handling, fuel handling, yeah, because fuel will be react with air, and then boiler feed water. Yeah, we have discussed about the boiler feed water, and then burner. Burner is the place when reaction of the combustion happen, yeah, burners and furnaces. And then we have evaporator, superheater, and reheater, yeah, because the heat, yeah, the heat that provided by the combustion, the heat that is brought by the gas, the combustion gas, can be used in the several steps. So we can use it for the evaporation process, and then superheater and reheater. Okay, this is the general design, yeah, of the combustion. And according to the position of where the hot combustion gas and where the water, boiler can be categorized as a fire tube boiler. So you can see from the name, fire tube boiler. It means the hot gas, yeah, the gas from the combustion, yeah, combustion is related to the fire, right? So the hot gas will flows in the tube. So you can imagine as a shell and tube part. Yeah, you have learned about heat exchanger, right? I think Pak Hendra already explained to you about heat exchanger, and one type of the heat exchanger is shell and tube. So basically, in fire tube boiler, hot gas will be in the tube, the water will be in the shell. And the opposite, water tube boiler, the water will be in the tube and the hot gas will be in the shell. So this is the basic design of boiler. Okay, I think I have one other video, so it's you are not boring. You are not bored listening to my explanation only. So I will show you some video regarding the boiler.
In this video, we are going to discover what an industrial boiler is and how it works. But first, let us consider the term heat. Heat is vital in everyone's day-to-day lives. Whether it be heat to warm up our surroundings or heat to be able to cook food, we all use it to some extent in our day-to-day activities. Water and steam are great heat carriers and are not damaging to our environment. The boiling point of water at atmospheric pressure is 100 degrees centigrade, or 212 degrees Fahrenheit. By pressurizing the boiling system, by giving it an airtight seal, we can actually increase the boiling point. This is how pressure cookers work. An airtight vessel to increase the pressure, to increase the boiling point. This makes the food cook in a much shorter time than if an open saucepan were to be used. So how does this compare with an industrial boiler? Well, for a start, industrial boilers can cope with pressures much higher than a pressure cooker. Industrial boilers are often made by welding together thick steel plates, allowing extremely high pressures to be made. It has to be made incredibly strong to cope with the high pressure, as failure to do so will result in forces close to an exploding bomb. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealPars videos. This way, you never miss another one. The function of a boiler is to either produce hot water or steam. Hot water boilers heat water for the purpose of domestic or commercial heating and hot water supply. Steam boilers generate steam in order to power turbines for power generation and various other industrial heating applications. To visualize the effects of steam generation using a boiler, think of the steam powering a turbine. When the steam passes through the blades of a turbine, the force turns the blades and accelerates the turbine. Steam contains an enormous amount of energy, so it makes the turbine quite efficient and, depending on the fuel used to boil the water, quite energy efficient too. There are different types of boilers for all sorts of different applications. We are going to cover a couple of the different types, including how each of the methods is able to generate heat, so you can familiarize yourself and be able to correctly identify them. Firstly, fire tube boilers. The typical makeup of this type of boiler is a furnace, a water tank acting as a boiler, and a smokestack. There are tubes running through the water tank carrying the heat from the furnace, and the smokestack vents the heat and gases caused by the heating effect so that the pressure does not continue to rise above the intended level. So, the fuel is burned inside the furnace. The tubes transfer the heat of the furnace through the water in the tank. Once it is heated, the steam generated is moved along downstream. Fire tube boilers tend to be the cheapest type of boiler to produce, as they have a fairly simple construction, but are typically limited for low to medium pressure applications due to the thickness of the outer shell containing the water. Now that we've covered the fire tube boiler, let's have a look at a water tube boiler. The design is fairly similar to a fire tube boiler, but instead of the furnace heating fire tubes to heat water in a tank, the furnace heats water tubes inside the furnace. In the same way, a fuel source is burned in the furnace, causing the water tubes inside to heat up. Once again, when the water is boiled, steam is generated and moved downstream. A water tube boiler is more thermally efficient than a fire tube boiler, but they are more complex to construct, and the quality of the water can be a limiting factor. The water may need filtering to operate most effectively. Combustion is the process of burning a fuel source. To create a reaction, there must be a fuel source, heat, and an oxidizing agent. Boilers can be designed to burn a specific fuel using any number of different technologies, but the main component to consider here is the heat source, or otherwise known as the fuel. The fuel is one of the most important aspects of a boiler, and is what burns inside the boiler to generate the heat. There are many different sources that can be used. Coal is a standard fuel source. In industrial boiler applications, the coal tends to be ground to a fine powder as it burns more completely than traditional bricks. Electric can be used as a heat source, either by resistance heating coils or electrode units. Electric would normally only be used for smaller commercial or domestic use. Electrode-type applications require very high water quality and conductivity to work effectively. Maintenance is key to electrode-type applications too, as cleaning the insulators is required to prevent arcing between the electrodes. Gas-fired boilers work by using either propane or natural gas, whereas oil-fired boilers work using gasoline or petroleum-based fluid. So let's now recap a few of the things learned today. Boilers are an extremely versatile and important piece of engineering equipment, not only for us on a domestic level, but at a commercial and industrial level too. There are so many different applications that boilers are used for. They are used in the food industry. Food at various stages of production needs to be heated or boiled as it is processed. Another interesting use of boilers is in the brewing of beer. During the beer brewing process, the malt needs to be ground and mixed with water, a process called mashing. This mash is then heated using steam for several hours before the yeast is introduced to trigger the fermentation. To generate heat, we need a fuel source. The reaction of having a fuel source, heat, and an oxidizing agent allows for a reaction to take place. This keeps the heat source going. By heating tubes of water and using fire tubes to heat a tank, steam is produced at extremely high pressures to produce enormous amounts of energy. Okay, that's all for today's video. If you've learned something new from this video, it would
Yeah, I think the video shows you the basic principle of the boiler, and then the types of boiler. Although in the video it was mentioned that there will be more types of not only fire tube and water tube, but basically this fire tube and water tube is the type of the boiler that commonly used in industrial scale. So maybe like oil. I mean the quite a big scale. For the small scale, you can use the oil burner boiler or maybe the electrical boiler. But for industrial, normally we use the fire tube and water tube. And the first figure is, you know this figure, right? This is the locomotive. Yeah, it's driven by the steam boiler. And the types of boiler that used in the locomotive is normally the fire tube boiler. And the second one is one of the biggest PLTU in Python. Python is in West Java. Yeah. Unluckily that we have the pandemic condition. I think last what year, Pak Hendra? Early of 2020, Pak Hendra and me accompany the TK3102. We went to the West Java to visit several plants, and some of the group they go to the Python together with Pak Heri, if I'm not mistaken, yeah, Pak Hendra.
Yeah, correct, Pak.
Yeah. Yeah, hopefully pandemic ends sooner, so we can you can go for the cooker. Okay. Yeah, this is the schematic diagram of the fire tube boiler. Yeah, basically you will have the furnace at the bottom part, and then the hot gas will flows to the tube. Yeah, so then the heat from the tube will be transferred to water in the cell, and the water will convert it into the steam. So this is the simple and also cheaper construction, yeah, compared to the water tube boiler. However, this arrangement is very susceptible, yeah, very prone to quite high risk, yeah, because if you have like corrosion, yeah, from the water, I think we have discussed about the corrosion or the scaling, it can rupture the tube. Yeah, what happens if you have a rupture of the tubes? It means the heat will flows freely, right, in the water, and it will result in rapid overheating of the large volume of the water. And what will happen if you have a very large volume of the water got overheated? Any idea what might happen?
Evaporator.
Not only evaporate. Yeah, your main purpose with the boiler is to increase the temperature of the water, right? So the water will change the phase into vapor. But the water is not, it's not only experiencing increasing temperature, but also experiencing increasing of pressure, right? Yeah, remember the steam. I think in thermodynamics, and also in thermodynamics you have learned about how to produce steam. So basically, when you have steam, it's not only the temperature is increased, but the pressure is also increased. What happens if you have overheating of large volume of water? It means you have overpressure as well. And what happens if you have overpressure of very large volume of the water?
Exploder.
Yes. So this type of fire tube boilers is prone to explosion, yeah, due to the rupture of the tubes. Yeah, so it means if the industry have this kind of fire tube boilers, the tube should be maintained very, very well. Yeah, for the, maybe it has to be maintained from the corrosion, from the scaling, from other falling, and etc. However, this is very suitable for a small unit of boiler, or we call it a package boiler. Okay, I think I have one other video regarding fire tube boiler. Okay, that video shows you the representative of the parts of the fire tube boiler. So I hope you can visualize what inside the fire tube boiler. Okay, next is water tube boiler. So basically, this water tube boiler is used if you want to have larger capacities and you want higher reliability. The capacity of the water tube boiler can reach until 3,000 tons of steam per hour. So this is used for one 3,000 megawatt turbine. So basically, in water tube boiler, you will have arrangement like this one. You have a steam drum, and also you have a mud drum, and then you will have downcomer, and you will have a riser. Yeah. Downcomer is the part that flows down, and riser is the part that goes up. So basically, in one part, you will have heat, will heat up the water, and then because of the vaporization process, boiling process happen, yeah. So the water will flows up, and this steam drum, you will have two phase of water. One is still in the phase of the liquid, and one is in the phase of the steam. So maybe I'll start from the feed water first. Yeah, feed water will goes down into the downcomer, goes to the mud drum, and the water in the mud drum is being heated, and then in the riser part, so the water will goes up, and this part will separate it into two phase. Yeah, just remember the steam leaving or the steam in this steam drum will in the saturated condition. Please remember again about the steam diagram in the thermodynamic. That will be one of use of the steam diagram. Yeah. So it will depending on the temperature and the pressure will be depending on the condition of the steam. Okay. So in the water heat boiler, so basically, if you have combustion gas, yeah, heat from the gas, it can be used first, the water, yeah, the water from the water drum. So if you have how to explain this one, I think I can explain it's from the combustion the heat from the gas first. So the heat is basically when the gas is flows up, the temperature of the gas will basically reduce, right? So the temperature at the bottom part will higher than the middle part and the top part. So basically, in the top part, the lower temperature will be used to preheat the feed water. We call it the economizer. Yeah, economizer. And then the heated feed water will go to go to the steam drum. Yeah. Yeah, this is the explanation. Yeah, boiler feed water will fed to the steam drum by boiler feed water pump. And then a portion of the water will be vaporized, and then the rest flows down to the mud drum via the downcomer tubes. And then hotter water will circulate up from the mud drum via riser due to the lower density. And then the riser and the steam drum will receive the radiative and also the convective heat from the furnace. And then steam bubble are formed along the riser, and then steam water mixture will flows up to the steam drum where the steam is separated from the water. Yeah, and then this what happened in this part. Yeah, and then the steam will flows up. Yeah, in saturated condition, right? Saturated condition, and then this saturated steam will receive additional heat from the gas. It becomes superheated steam. That's why we call this part is the superheater. Okay, some of the water from the mud drum, yeah, will be circulated into the evaporator, yeah, to increase the temperature, to change the phase into vapor, and back to this one. Okay. Upon exiting the riser tube section, the temperature of the combustion gas produced by boiler is still considerably high. Yeah, I have explained this. And then the hot combustion gas from the evaporator section is then it will be used to heat the steam produced by the steam drum. So it becomes the super heated steam. Yeah, from the saturated temperature, it will increase into the superheated temperature, yeah, superheated steam. And then to improve the thermal efficiency of the boiler, the gas that existing the riser or the vaporizer section and then can be used to preheat the boiler feed water before it's being fed to the mud drum. That's why we call it economizer. And then finally, the combustion gas can also be used to reheat the steam that circulated from the main process. The location is the steam preheater. Yeah, steam preheater within the boiler depends with the location of the steam reheaters within the boiler will depends on the required steam temperature. Okay, I think this is the diagram of the boiler tubes arrangement. Yeah, where is the superheater, where is the reheater, and then where is the economizer, where is the boiler drum, and then this is the furnace, and etc. Okay, yeah, the left one is from, I don't know, is it still, oh yeah, it's still Python, it's in the Python. This is very big, large cold fire steam power plant, yeah. And the right one is the compact fire tube package boiler. Okay, until this part, do you have any question? Or maybe from Pak Hendra, you want to add something, Pak?
Yeah, Pak Wawan, thank you for the opportunity. Yeah, so I think based on Pak Wawan explanations, yeah, we have already learned regarding the type of the boiler. So you have to see the difference between the type of the boiler. So as Pak Wawan explained that we have 3 types of the boilers that is actually commonly used in several power plants in Indonesia, especially. Yeah. So we have 3 types of the boiler. So we call it stoker, pulverized coal, pulverizer coal, and also the circulating fluidized bed. Yeah. So actually for the fluidized bed, we have actually another type which call it the bubbling fluidized bed, yeah, or we call it BFB. Yeah. So based on these 3 types, so you have to consider also several parameters that need to be considered. Yeah. So the first one is regarding the mean particle size of the solid fuels, yeah, which is actually the particles of the coal, or maybe at the moment, yeah, is actually developed Indonesia, especially try to develop. We call it the coal firings, yeah. So we use also the solid fuel as a mixtures of the coal and also the biomass, yeah. So we have to consider the mean particle size of the solid fuels, yeah. So based on Pak Wawan explanations, which type of the boilers that is actually need lowest particle size for the combustion process? Anyone have an idea? So the mean particle size of the solid fuel, yeah, especially.
Is it the 200 mesh things then?
No, I mean, which type of the boilers that actually can use the lowest size of particle? So we have the pulverizer coal, we have also circulating fluidized bed, and we have also the stoker. Yeah? So which one do you think this type of the boilers can facilitate the lowest size of the particles to be proceeded for the combustion process?
Fluidizer?
Yes, fluidized, yeah. So the fluidized one is actually the lowest particle size. Yeah? So it's around 5 until 15 micron, I guess, or millimeter. Yeah. But the PC, the pulverizer coal, also can also achieve low particle size as well, yeah, until micron size. Yeah. So despite the particle size, you have also to consider the, what do you call it, the the emissions, yeah, because the emissions are actually very important parameters that need to be considered, yeah. So the emissions from the commonly from the pulverized coal and also from the stoker type of the boilers is very high, yeah. But you can use, as Pa Wawan says, you can use the desulfurizations, yeah, desulfurizations units, yeah. We call it, what do you call it? Pa Wawan, I forgot. Desulfurizations. Yeah. So one operation unit, yeah, we call it to remove or to collect the sulfur, yeah, in order to prevent the highest amount of the sulfur being emitted, yeah, from the process, yeah. And also, so that's why the CFB is actually commonly used, yeah. But in Indonesia, so for your insight, yeah, in Indonesia we have in total around 52 power plants, yeah. So, but it's actually for the type of the boiler is randomly scattered, yeah. So around 37%. So 19 out of 52 power plants use CFB. 19 out of 52 use also the PC, yeah, and 14 out of 52 use the stoker, yeah. So it depends also it depends also to the capacity, yeah? The capacity of the electricity that is actually generated, yeah. So the higher the capacity, so which means that you have to also consider the type of the boiler, yeah? Usually if we like the Python, yeah? In Pythons, Pa Wawan already stated that there are actually a lot of units, yeah, in Pythons, but the capacity of the Python is actually higher than around 400 megawatts, I guess, yeah, for per unit. So you can see in here, yeah. So 400 megawatts, 610 megawatts, yeah, and even in unit 3, it actually generates 800 megawatts, yeah. So the type of the boiler that is actually being used in Python is the pulverizer coil, yeah, or the PC boiler, yeah. Because the PC boiler has the highest capacity compared with other type of the boilers, yeah. So the CFB usually the maximum is around 350 megawatts, yeah. And for the stoker is more or less, yeah, it's actually around maybe less than 30 megawatts, yeah. So if we have the small capacity of the electricity generated, yeah, so we can use the PC the stoker type of the boilers, yeah. But if we have the higher capacity, it will be suitable to use the pulverizer coil, yeah. So in here you have to try to explore, yeah, why PC boiler can actually generate higher capacity compared with the stoker and CFB, yeah. So this is actually your homework to explore it, yeah. But again, I just want to give you kind of the take-home message, yeah. So you need to consider several parameters, yeah, for using the type of the boiler. So the first one is the particle size of the solid fuel, the emissions that is actually generated, yeah. The third one is the capacity of the electricity generations, and also the combustion temperature. Yeah, it's very important also, yeah. So as Pa Wawan stated, that the combustion temperature is very important, especially when we want to reduce the emissions, especially the NOx, yeah. So it is better to use the lower temperature, yeah, it's around 800, maybe 800 degrees C until 900. But for general cases, yeah, for the general cases of the in the power plants, usually, yeah, especially for the PC boilers, is the temperatures that is actually used is commonly from the range of 900 until 1100 degrees C, yeah. But there is actually several developments technologies, yeah, in order to prevent the NOx and SOx emissions and also the CO2 emissions at the moment, yeah, by using for example, CCUS, yeah, carbon capture, utilization, and storage, and also other technologies that can prevent or reduce, yeah, this type of the emissions, in order to, especially in the near futures, yeah, the government will give kind of the carbon tax, yeah. So for the both power plants or industry that actually generate the carbon dioxide emissions, that they need to pay some money, yeah, to as a consequence that they emitted the pollutions, yeah. So that's why in this case, rather than the industries must pay money for the emissions, that then the industries at the moment try to develop new technologies or try to adopt the technologies from the abroad, yeah, in order to reduce this kind of the emissions. Okay, So yeah, I think that's my additions, Wawan, regarding the type of the boilers that is commonly used in power plants, especially in Indonesia. Thank you, Pak.
Okay, Pak Hendra, thank you for your explanation. Did you go to the Python plant last 2020, Pak Hendra, together with
No,
Pak
Pak, I didn't get the chance to Python. I'm in a separate group.
Yeah,
other
me
group.
also, I go to the Unilever, if I'm not
Yeah.
mistaken. Okay, thank you, Pak Hendra, for the further explanation. Actually, while Pak Hendra explaining, I was WhatsApping with Pak Miki asking about the S fusion because I'm curious. So basically, S fusion is the phenomena when we have very high temperature, the S will be converted into very small particle. Yeah, so it's basically like melting down of the S. So if the S is melting down, it will goes up with the flow of the gas. It cannot be captured, yeah, because previously if we have fly ash, you can capture it with the cyclone or the electrostatic precipitator. But if the ash is melting down, it will carries to the next step, and or maybe it can stick to the heating surface. Yeah, it can stick to the heating surface, and then it can make problems in the heating surface. It can create corrosion, it can create ruptures, etc. So that's the problem with the ash fusion. Okay, any question from students? Okay, if you have no question, our next discussion is about the energy balance of the boilers, but I think we should leave it to Pak Miki next week. Okay, Pak Hendra. So we will stop our discussion until boiler part. I hope you can understand what me and Pak Hendra is explaining to you. If you still have further question, please ask Pak Miki next week. Okay, thank you very much. Good afternoon and keep safe and healthy. Thank you.
Okay, thank you, Pak Wawan. Thank you, all students. Stay safe and healthy.
Thank you, Bawa.
Thank you,